Today, we are going to tackle one of the most critical, and let's be honest, sometimes super frustrating concepts in Salesforce development, Apex Transaction Control. I promise, by the end of this, you'll get the simple, unbreakable rules that are going to make your code so much more solid and predictable.
You've been there, right? We've all been there. You run this complex piece of code, it's processing tons of records, and just when you think you're about to cross the finish line, one single, unexpected error happens, and then poof. All that work just vanishes like it never even happened. That whole all or nothing thing, that's Apex Transaction Control in action, and really understanding it is the secret to avoiding those headaches.
All right, let's dive right in. To really get what's going on, we have to start with the most basic piece of the puzzle, the Apex transaction itself. And to make this easy, I want you to picture building something with blocks.
So an Apex transaction isn't just a series of small independent steps. Nope, it's a whole set of operations that Salesforce treats as one single event, one big indivisible unit. Going back to our metaphor, you're not just placing individual blocks one by one, you're trying to build one complete final structure all in one go.
But here's the thing. There are only two possible outcomes for that structure you're building. Only two. As your code runs DML operations, inserting or updating records, you're adding blocks to your structure. If every single step is a success, the whole transaction commits and your structure is saved permanently. But, and this is the important part, if even one unhandled error pops up anywhere, the entire thing gets rolled back. The whole structure is demolished, leaving the database exactly like it was before you even started.
Now this brings up something that confuses a lot of people. If nothing is really saved until the very end, what can your code actually see while it's in the middle of everything?
And this is absolutely crucial to understand. Even though your changes aren't committed for the rest of the world to see, your own transaction is totally aware of its own work in progress. So if you insert a new account record, and then right after that you run a SQL query, your code will find that new record. It's kind of like you can see all the blocks you've placed on your own building table, even if nobody outside the room can see them yet.
Okay, now for a rule that trips up developers all the time. It's a hard and fast rule designed to protect the integrity of your transaction. This is all about when you need to talk to systems outside of Salesforce. And believe me, the order of operations is not negotiable.
Let's be crystal clear about this. A DML operation is you changing the database. A callout is you reaching out to some external system. The rule is you cannot do DML before a callout in the same transaction. Why? Well, think about it. Once you've made a change to the database, Salesforce is basically holding that change, waiting for the OK to commit it. It can't let you go off and talk to some external system it has no control over, because what if that external callout fails? Salesforce has no way to tell that other system to roll back. So, to keep its all-or-nothing promise, it forces you, do your external work first.
And this slide lays it out perfectly. This is the only way it works. You have to make your external callout first. Go get whatever information you need from the outside world. Once that's done, you can then do all the database operations you want inside your transaction. Just burn this into your brain. Callout first, then DML. Any other way is going to throw an error and blow up your whole transaction.
So, what if you're building a really complicated structure, and you don't want one little mistake to bring the whole thing crashing down? What if you could, save your progress partway through? Well, good news, you can. And this is where we get into a more advanced technique called a save point. A save point is pretty much exactly what it sounds like. It's a temporary marker that you intentionally place in your code using database.setSavePoint. The best way to think about it is like pausing your build for a second to take a quick photograph of your structure, exactly how it looks at that moment. It's a snapshot of your progress.
And here's where the real power of a save point comes into play. So your transaction kicks off. You do some DML, let's say you build the first floor of your structure. Then you set a save point. You take that snapshot. After that, you start working on the second floor, but oops, something goes wrong. Well, instead of the whole building collapsing, you can just call database.rollback and point it to your save point. This tells Salesforce, hey, just demolish everything we built after that photo was taken. It brings you right back to that moment in time, and guess what? That first floor is totally safe.
All right, let's pull all of this together and lock in these concepts with a final blueprint. Seriously, remembering these key takeaways is the difference between writing code that might work and building professional, rock-solid applications.
This slide right here, this is your cheat sheet. Let's run through the 4 unbreakable rules one last time. Rule 1, all or nothing. The transaction either fully commits or it fully fails. There's no in between. Rule 2, you can see your own work. Your code can query the changes it's making as it goes. Rule 3, callouts first. You must make any external callouts before you touch the database with DML. And finally, Rule 4, save points offer control. For your more complex logic, use save points to create these partial rollbacks and stop a small problem from becoming a total failure.
And that leaves us with a final thought to chew on. Take a minute and think about the projects you're working on right now. Is there some big, complex process in there, maybe one that's updating a bunch of related objects? Where could you strategically place a save point to gracefully handle a partial failure instead of just letting the whole operation collapse? Because mastering that technique, well, that's what separates good code from truly great code.